Am I audible, sir? Yes.
Yes, you're audible.
Yeah. Hello, everyone. This is Sailee Abhale. We'll soon start the session if more attendees join. I guess they're joining, sir, right?
Yes, they are joining. We'll be
Okay,
waiting
sir.
for a moment. And meanwhile, they can have the attendance.
Okay, sir. Should I start the screen sharing?
Yes, sure, please. I think we can begin. Meanwhile, everyone joining. Shally, please go ahead.
Yes, sir. One second. Hello everyone. Warm welcome to the Student Symposium on Artificial Intelligence and Data Science 2025. We are thrilled to have you all join us for this 3 day symposium hosted from the Finessefleet headquarters, Bangalore. Before starting our session, let me read out some guidelines for you all. First, the session is being conducted via Microsoft Teams and hosted from the Finest Split headquarters, Bangalore. After the session concludes, a recorded version will be made openly available and a consolidated list of recordings will be shared via email. Second, a dedicated Q&A session will take place at the end of the talk. Participants are requested to hold their questions until then. However, they may submit their queries in advance through the Q&A section, which will be moderated. Third, video and audio must be turned off unless you are speaking. If you wish to speak, please use the raise hand feature and the moderators will grant you the opportunity. Fourth, attendance will be recorded through a dedicated form which will be shared during the session. Kindly ensure that you mark your attendance by filling out the form when it will be asked. All attendees must attend the symposium across all 3 days, otherwise, they may not receive the certificate of participation. Fifth, after the session concludes, the host will conclude the meeting for all the participants. Now, let me introduce our today's speaker, Professor Elakkiya is an assistant professor in the Department of Computer Science at the Birla Institute of Technology and Science, Pilani, Dubai campus. She holds a PhD in computer science from Anna University, Chennai, with research focused on sign language recognition. She has previously served as an assistant professor at SASTRA University, Tanjavur, and has been a recipient of research grants, including the DST SCRB Startup Research Grant and the Indo Russian Joint Grant. Her research interest includes artificial intelligence, machine learning, natural language processing, deep learning, and computer vision. She has authored multiple research articles in journals such as IEE, Elsevier, and Springer, holds several patents and has contributed to funded research projects in AI applications. She is a member of the ACM and IAENG and actively participates in peer review and conference committees. In today's keynote session, Professor will delve into the generative AI models. I now request our today's speaker to please take over this session.
Thank you. Thank you, Sailee, for the warm intro. So let me share my screen. Is my screen visible? Hope so.
Yes, ma'am.
It's fine. So today I'll be taking you a deep dive in terms of generative AI models. So mostly I'll be concentrating in terms of LLMs and GANs. So today's landscape is all about generative AI, and in that I'll be explaining then how we are using LLMs for processing the languages, then the math behind GANs and the working of LLMs. So the research vertical that currently I'm working in terms of this LLMs and GANs, certain industry products that we developed here and delivered to the industries. So that is a myth. People are still believing that generative and AI and LLM are the same, but actually we can't say both are same. But they are a part. LLM is a part of the generative AI model. What exactly then Gen AI is? So the generative AI is something which has its ability in terms of producing or synthesizing something new based on what it actually learns. There is a neural network model behind every generative models. So what exactly this generative AI is going to do? Now, as I said, we know there is a neural network. What exactly this neural network does? It trains itself. So the neural network trains itself in order to interpret. So it is trying to interpret what? If it learns, with respect to images, it tries to interpret what sort of images it keeps learns. And based on all the set of series of images it is getting trained into, it will try to synthesize or produce something new that is of what kind of images. Suppose it learns about series of cat images, it could have the ability to come up with a generation of new cat. If it learns in terms of or trained with several features in terms of flowers, then it could can create a new flower image. So that is how. So what exactly we are feeding in, that way it will replicate or create a new content. If it learns audios, it has the ability to create audio. If it is a video, then it can synthesize the video. So what is the training that we are giving in the backend? That always matters in terms of synthesizing something new in the front end. So that is the capability, or that is what we are calling it as generative AI. So what exactly the application that we are running behind this generative AI model? Whenever it comes in terms of generative model, as I said, it has the ability to create or synthesize every time something new. Because of this creativity, we feel this world is something so creative and interesting place to interact with, right? Now, every day-to-day problems we can easily solve using generative AI. These generative AIs actually has the possibility or the ability in terms of, sorry, some people are waiting in the lobby, it seems. Kindly admit them. So it has the ability to solve the problem and it is communicating in a better way. So it makes people enjoy themselves more. Now, when we are asking for certain email, these generative AI models understand and tries to interpret what exactly the content it wants to deliver or we want to deliver in such a way that it is trying to make people feels comfortable. So the convenience is being given by these sort of generative models. Is it drafting only email? Is it only text content being generated by these generative AI models? Not really. Then what else it is generating? If you ask the model to come up with certain programming codes, or you want the model to debug your code, yes, it is doing. If you ask some DALI, can you generate so and so image with so and so features, it could create a model in terms of image. If I'm asking my DeepSeek, can you just generate a code for so and so issue, or can you come up with a new model and innovative solution for so and so problem? It creates its own new neural network where we can just train on in our own application, our own data set. It is all now possible. So generative AI is growing like anything. So the application is beyond our limitation. So everywhere we can use it. How exactly it started? Is it something new? Because now we are saying maybe after the evolution of ChatGPT, people are saying that Gen AI, Gen AI, Gen AI. But actually, this is not something new. Because in the year 2014 itself, when Ian Goodfellow introduced this adversarial networks, from there GANs came into picture. If you see in terms of text, it is LLMs. But apart from that, image, video, audio, whatever may be the mode of data, it is all being the backend or backbone behind all these modality. If you see, it is GAN. So that is not actually a new evolution. From since June 2014, it is into existence. So now GANs, it is the one which is becoming a cornerstone in the field of Gen AI. So the evolution, if you see, it started in the year 2014. What exactly these GANs are? In every GAN, what any generative AI model, if you take, there is a neural network. Now, in terms of this GANs, we have two neural networks. One is the generator network, the other one is the discriminator network. This generator is the one which always tries to produce something new based on what it is being trained with. Then what is the role of discriminator? Why do we need two different networks? To improvise the performance of generator in synthesizing new content. This discriminator is going to play a role like police. It always tries to discriminate what is being originally fed into the neural network, what is being generated or produced, synthesized by the generator. Whenever it discriminates the generator generated image and the real image that we are having in the data set, till then the discriminator outperforms the generator. after the generator actually understood how actually the real image is. So it learns the distribution of real images, then it start producing something similar like real. Then in that case, discriminator will fail to discriminate which is real, which is fake. So that is how the generator improves its performance, and then the discriminator performance will be bringing down. So now, since our task is generation, so creation, something we are trying to produce new, which is not already there. So we want the generator to outperform. So in that way, we can synthesize something new. So this is how the generator and discriminator is going to work on. So now we'll be having a discriminator model. In this discriminator model, if you see, we have features alone. So discriminator will be fed with the features, that is the real image, or it can be a fake image. It needs to categorize the real and fake. So is it a real image or is it a fake one? That is, the fake one is being generated by the generator. So that is the role of these discriminative models. That is nothing but the discriminator. This generator actually doesn't know the real feature or the real image distribution, but we are going to say the domain alone. So we'll be just giving what exactly the domain it belongs to. So along with that, some random noises being added, and it will try to create the feature. That feature, if you see, it is close to what exactly the input that we are considering, that is X. So here we are trying to come back or bring the or produce something new in terms of real images. So that is the task of generative models. Now, what are the different variants do we have in terms of the GANs? It started, the evolution started with vanilla GAN, the very most basic form of the GAN model. So it utilizes this multi-layer perceptron concepts. So I hope you might be aware of a single layer and multi-layer perceptron. So whenever it is a multi-layer perceptron, then you will be having more than one linear equation to distinguish the classes into two different data points into two different classes. So whenever it is not possible for us to just go with one single line, so now the data point is something like this. So I just want to distinguish or differentiate the data points of crosses and circle. One single line is enough. But in this case, if you see, one single line could not actually solve this. So we need to go with multiple lines which can actually segregate the circle and this cross classes. So in that case, we call the perceptron as multi-layer perceptron. This vanilla GAN, both discriminator as well as generator model adapts this multi-layer perceptron, and that is a very basic form of the GAN. The second type of GAN is a conditional GAN, where they tried making the model more conditional in such a way that during the training of discriminator model, the network receives the class label as well. It's not only it is going to make based on X, it is not going to predict only Y. So let us make it supervised. Both X and Y being fed into the model, then Y we are trying to predict whether it is a real or fake. So that way this conditional GANs actually differs from the basic GAN. Next level of GAN, if you see the deep convolutional GAN, instead of MLPs, people started using CNN in terms of both discriminator as well as in terms of generator model, mainly for the image data to handle the images. So when it comes in terms of 2D, both they started using this CNN layer network in both discriminator and generator. Then there is another variant which is called as cycle GAN. So when people wants to translate their image from one form to another form, when you want to just change your background from the summer kind of landscape to winter ones, then we can go with this cycle GAN. Similarly, style GAN will also do this. So now suppose I have a picture, I just want to make the style in terms of most art and creativity. I just want the image to be like a pencil sketched one. Then I can go with this cycle GAN. Then likewise, we have a super resolution GAN. Whenever your picture is of low quality and when you want to enhance the image resolution, then we can use this SR GANs. So these are certain variants of GANs. So where exactly this can be used? When you want to translate the images, when you want to synthesize the image from the text or from the image to text conversion, that is labeling the image. Everywhere, actually, we can use this GANs. So next, let's move in terms of LLMs. So with respect to LLMs, in terms of GANs, as I told you, if we are training the model with image, then the production will be also image. If you are training the model with video, you'll be getting only video. If you are training the model with audios, you'll be getting the output as audio. But when it comes in terms of large language models, the LLMs, if you see the training data, the LLMs being trained with text, image, speech. It can be even the structured databases like tables, queries, whatever it is, code snippets, knowledge graphs. So every modality we are using in terms of training these LLMs. If it is a text, then directly it actually takes or extracts the real features and then it trains. If it is an image, then it will try to look for where exactly the text which describes the image and all, then the extraction will be there. If it is audio, again, audio to video using some Whisper AI or something, we can actually extract all the text features and then the LLM is training. So likewise, in terms of training the LLM, any modality of data can be used. But when it in terms of the output, all the tasks done by the LLMs are actually based on text. It is not like the LLMs are going to do something else. Everything on the basis of text. Now, if you see LLM with respect to text summarization, I may have some hundreds of documents, 10 documents, let's say. I just want to have an overview of what is there in those 10 documents. Then LLM can do that. I just want to convert or translate one complete document to from English to French, let's say. Then that is also feasible. I just want to capture the emotion behind some plenty millions of words. That is feasible. I can just categorize or group the documents into different classes. Even we can go with code generation or in terms of virtual assistant development. Anything can be done. But everything, if you see in terms of the task being performed by the LLM models, it is purely based on the text. But the modality it uses in terms of training may be multi-modal. But when it comes in terms of the GANs, which exactly the mode that we are using or which exactly the data that we are going to use, that way the synthesis will be. So what exactly or how exactly these large language models being built? So we always say that all these LLMs are being built with billions of parameters so that it is able to behave or create the text which is of more humankind. What exactly these billions of parameters? I'll just cover it in the upcoming slides. But all the LLMs, because this is named as LLMs. Why it is named? Because it handles or it is being trained with millions of parameters. So based on that, it understands what it is and it is trying to create something in terms of human-like text. Again, LLMs are not something very new. If you see, in terms of LLMs, this is again a concept from natural language processing. And this natural language processing, it is a very old concept. And from 1960s onwards, this NLP is into existence. Initially, in 1954, if I'm not wrong, so people started developing a rule-based system like Eliza Shulu. So this is mainly why they have done is first NLP-based processing. It comes into picture in terms of translating Russian text in terms of English. So that is how first existence. Then they tried developing a chatbot, which is again a rule-based one. So that mainly answer the questions in terms of baseball. So that is the second system. That comes in terms of 1960s, 70s, somewhere like that. Then people started looking in terms of NLP more serious. So in the year 1980s, 90s, if you see, they started using statistical language modeling. So this statistical language modeling is something where, how exactly the probability can be used here in terms of occurrence of the terms. Is the term occurs multiple times in the document, or the occurrence of co-occurrence of two terms occurs multiple times in the document, or occurrence of three words together multiple times in the document. So likewise, they tried bringing out the probabilities in terms of unigrams, bigrams, trigrams, and then any n-grams. So that is how people started developing the model in the later stages. From there, actually in 2013, Google's Word2Vec came into picture with this multi-layer perceptron into account. So here people started looking the terms. Instead of raw counts, people started looking the terms as embeddings, that is projecting the terms in some multi-dimensional space and try to correlate how one and the other word is related to each other. This is how 2013 this Google's word to wake came into existence. It's not just checking the count, instead it tries understanding the semantic relationship between the terms. Later, if you see this LLMs, if you know, it is the backbone of your LLM is a transformer. And this transformer, it is not something very new. Again, in the year 2017, attention is all you need. There is a paper. So that is the one which is being initially developed or introduced the concept of this transformers. So this paper actually introduces something which is called as attention mechanism. You know, instead of using 1 gram, 2 gram, 3 gram, 4 gram, something like that. Sorry. Okay. So this transformer in terms of attention mechanism has the ability to actually understand or gather the long range dependencies. It tries to capture the longer range dependencies in terms of sentence level. It's not 1 or 2 terms, 3 terms, 4 terms it is being considered. Instead, a sequence in terms of terms, that is a sentence or paragraph. Then it tries linking between how one term and the other term we can relate. Why in a particular paragraph the terms repeatedly called, a person name is being referred multiple times. All these comes into picture when the transformer series comes into place. So this is how it is being started, and this transformer is being adapted by the chat GPT models, and from there it is all being started. I don't know. Is someone asking question or something? It's not like every time we have to go with a subscription based. There are several open source LLMs are there to interact and to satisfy our needs. Now we have DeepSeek into existence, but we know there is an issue in terms of DeepSeek. Always the server getting crashed. Apart from that, it helps in terms of the coding wise. DeepSeek is very stronger. Even mathematical wise, if you see, DeepSeek is very stronger. One of the open source LLMs now in the market. So from where it started, if you see from the Hugging Face Llama model. So this model adapts transformer and it is being trained with almost 70 billion parameters. It has 3 different model sizes, 7 billion, 13 billion and 70 billion. Almost this Llama 2, if you see, it is being pre-trained with 2 trillion tokens and it has the ability to generate the context length of 4096 tokens. Similarly, we have Vicuna. Again, it is a transformer-based model and it is being trained with 33 billion parameters. 2 variants in terms of model size is available, 7 billion and 13 billion. So 370 million tokens are being used in terms of training this model. But though it uses only 370 million, it has the ability to generate the context length of 16K. The next model is Falcon. So actually, Facebook tries to bring out Falcon and only with decoder part. In terms of transformer, there is encoder as well as decoder. But this Falcon, they want to bring down or make the model lightweight and they used only the decoder part. But with the help of only decoder, this model is being trained with almost 40 billion. It's not less than this, right? 40 billion parameters the model trained with, and it is available in terms of 2 variants. One is 7 billion and the other one is 40 billion. And if you see, the model is again trained with 1 trillion tokens. The unique speciality of this Falcon model, if you see, it can respond multiple queries at a time. In terms of GPT, you have to ask one question and you have to wait for its this Falcon, it has the ability to respond to multiple queries at a time. And then this Mosaic pre-trained transformer. Again, this is a transformer model. This is being trained with 30 billion. And this is one of the best model for writing these stories. And the stable LM, again, this is one, again, decoder only model. And it is, you can see, very lightweight model, just 7 billion parameters, but it is being trained with 1.5 trillion tokens. So what exactly the math behind these GANs? So as I told you, always GANs will have two components. One is the generator, other one is the discriminator. So both of them will have some neural network. Either it may be a convolutional model or it can be something in terms of fully connected neural networks. Both will be having the same set of architecture. It's up to you which model you want to adapt in terms of the generator architecture and discriminator architecture. But in terms of generator, always it maps some random noise vector so that it can synthesize some real data samples. In terms of discriminator architecture, always it is being distinguishing the real and the fake samples. How it happens, what happens behind between these two generator and the discriminator? Always the training will be called as adversarial training, because this generator and discriminator is going to play an adversarial game. That game is called as min-max game, because the generator always aims to fool the discriminator by generating something real. This discriminator always wants to learn and differentiate which is real, which is fake. So the generator wants to maximize its performance by minimizing the performance of the discriminator. So this is nothing but min-max game. This is being happening in terms of adversarial training. So now the math, how this generator and discriminator works. So in terms of generator, we are going to consider the math as a joint probability distribution. So P of x comma y, because we are trying to predict, or the generator tries to synthesize x based on the class and the prior probability of the class, because it knows only the data distribution, but it doesn't know what, only the domain it knows, but it doesn't know what exactly the data is, how the data is being distributed. All these information doesn't known to the generator. Because why the domain knowledge we are giving it to the generator? Because it should not generate something else, because it starts with some random noise. It should not generate something, because if all these are cat images, the generator also needs to generate cat. It should not generate Mona Lisa image. So for that reason, we are feeding the generated model with the domain knowledge, not really the real-time data, the data that we are considering or giving it to the discriminator. Now, when you see the discriminator, it is a conditional probability. Generator always works in the basis of joint probability distribution. Discriminator, if you see, it works on the basis of conditional probability distribution. So in terms of conditional probabilities, because we know what is x and we are always trying to predict what is y. So y given x is what we want in terms of discriminator. So now just consider the architecture in this way. So we have a discriminator and we have a generator. So the original data x, we are directly feeding it to the discriminator with the class label y. Now the random noise is being passed on to the generator, and the generator just utilizes that noise and reconstructs some data, because it knows only the domain distribution, domain knowledge, but it doesn't know the data distribution. So some reconstructed data, and that data also being fed passed to the discriminator. So now that data, whatever is being generated from the generator, we are labeling it as 0. Now the discriminator needs to decide whether it is 0 or 1. That is the task of this discriminator. Now if you see, there is a generator, there is a discriminator. So we have two architecture, generator and discriminator. This takes the X data and this takes some random noises input. Generator takes the random noises input and something we are reconstructing. Now the original data distribution is because whenever it comes in terms of image, audio, video, it will be a multi-dimensional representation. Actually, we can't visualize it. It's so complex. But for understanding purpose, here I have just plotted it in terms of just two-dimensional data. Let us consider this is a data. So we have X and its distribution with respect to the probability. So this is original data. Let us now consider the noise as uniform distribution, because initially we don't know anything about the data. So let us just consider the data distribution of the noise is just uniform distribution. Now, this noise the generator takes, and the domain knowledge, you can see here, PG of X I have taken. It's not PD, I mean P data of X. It is just PG of X. It means that only the domain knowledge is being exposed to the generator. So based on the X domain knowledge, the generator reconstructs something, and this we are visualizing in this format. So X and PG of X. So this is how the data distribution, the three data that we are going to consider. One is P data, PZ and PG. So this is how we are considering. So what exactly this theta G and theta D? This theta G is nothing but the training, because as I told you, there is an adversarial training being happening to generator and discriminator, because initially it is just a uniform distribution. After understanding the domain knowledge, and whenever the discriminator rejects it is fake, 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 the generator is going to understand, okay, this is not a one, this is not a one, this is not a one. Finally, yes, this is what. So it's keep on learning or updating its parameters. So that weight parameter updation we are going to deal in terms of generator as del G. For discriminator, we are considering this in terms of del D, the same thing. Now, this adversarial training, we are going to call it as value function. So what is the value that the generator and discriminator is going to give us? Finally, some probability function. So now this value function in terms of adversarial training, that is min max, because the generator wants to minimize the performance of discriminator and improvise or maximize its performance. So that is why it is min max in terms of value function. So now you can see this is some notations you may see. So here it will be log, and people might have used minus here, or you can just use ln in terms of expectation with respect to base E, or in here plus. So anything is fine, any one notation we can go with. So now expectation with respect to real data, real samples. That is the real sample, you can see we are directly passing it to the discriminator. So ln of dx. Now the noise, that is PZ that we are actually Z in terms of PZ that we are passing it to the generator. Then from the generator, we are passing it to the discriminator. So this is ln 1 minus D of, because discriminator, before passing it to the discriminator, it goes to G of Z. So here you can see before getting into discriminator, it is reconstructing the data, that is generating something new, and then it passing it to the discriminator. So it is dg of Z. So this is what the value function is. If you look closely into this value function, it is mostly related to the binary cross entropy. So what is binary cross entropy? Again, it is a minus summation y ln y hat plus 1 minus y ln 1 minus y hat. So now when exactly y is equal to 0 or y is equal to 1, what happens? Whenever y is 1, then only this function remains. This will become 0, right? So now in that case, whenever the uh, your GAN or the discriminator tries to discriminate the class as 1. Whenever it is class 1, it is real, right? So whenever it discriminates the real samples, then the discriminator, the generator part actually fails, right? So we'll be ending up only with the discriminator part. But now, whenever it is a fake sample, so it is 0 and the discriminator fails to discriminate it. So in that case, only the rest of the second half will be there. The first half won't be there. So it is ln of 1 minus dg of Z. So this is what we are going to have. When we add these two together, then we'll be getting this value function back. So this is the reason we are going to compare this value function in terms of cross entropy function. So now, whenever it is the data, if you see it is just discrete, then in that case, expectation we can just call in terms of summation. That is fine. But whenever the data is continuous, then we can't actually use the expectation, but you have to use the integral. So in whenever it is an integral, you add the integral in the front and add dx at the back. So similarly for C, that is noise, add the integral and add dz. So this is with respect to the value function. So how the adversarial training is going to happen. Now let's see. So how the training happens. Now let us just fix the learning of the generator part. Let us consider some and every fake sample, whenever the generator generates, it always tries to generate something new. So in this case, for all m samples, it is going to update its weight. So how the updation happens, if you see this ln in terms of 1 minus d, and you can see here always the training in terms of generator involves gradient descent, that is minimizing the error in terms of, or minimizing, it tries to minimize the error so that it can maximize its performance. Now in terms of discriminator, the same m samples, if you see, So discriminator in both the cases. Here you can see the first half is not there. Ln d of x, it is not there because there is no generator is being involved in this case. So we are not going to utilize. Only the second half of the equation involves a generator. So only this part we are training. But in terms of discriminator, both d of x as well as d of g of z both involves discriminator. So we have used both the functions here. Now here if you see, it is gradient ascent. That is, this discriminator wants to improve its performance in terms of discriminating which is real and fake. So here it is gradient descent and there it is gradient ascent. When exactly this training needs to stop? Because it is keep on training, but at one point it needs to stop, right? So when exactly we are going to stop, or when we say the performance is either of discriminator or in terms of generator is being achieved? To be frank, we'll be saying that it is a global optimal point whenever the generator got its ability to generate something equivalent to that of the data that we are considering. Then in that case, we are going to say we have attained the convergence point. Till then, the training has to happen. Whenever the discriminator fails to discriminate real and fake, it means the generator generates this data which is so realistic. Then the discriminator will obviously fail because it couldn't actually discriminate which is real and fake. In that case, we'll be reaching the global optimality. So now let us consider this is our actual the discriminator, how the function of the discriminator is. Some discriminator function we are considering. This is the real-time data and this is the data, initial data that we are considering in terms of distribution. So some uniform noise we have taken and then the real-time data distribution. This is the discriminator function, the model of the discriminator. Now when we are updating the parameters of the discriminator, suppose the discriminator learns about the actual data and it performs something, tries to fit actually what is there in the uh, actual data distribution. Now, this is only the discriminator is being trained. When the generator is trained, now from the uniform distribution, this will also try to match up what is there in the real-time data. So when the training happens, keep on the iterations is going on. Now, if you see this generator generates something which is real, that is P data and PG, both are same. After this point, the discriminator now fails because there is no point in improving or updating the weight parameters of the discriminator because now the generator generates exactly the same data like the realistic one. So now always the probability, if you see, it will be 1 by 2. It can be real, it can be fake. So this is the exact divergence point. What value we need in terms of probability is 1 by 2. So the convergence happens whenever it is PG is equal to P data. Now this divergence we are attaining in terms of JS divergence. So the probability is whenever it is exactly 1 by 2. JS divergence is nothing but Shannon divergence. So when we are getting the probability as 1 by 2, then we can say that discriminator completely failed in terms of discriminating which is real and fake. So this is the math logic behind the GANs. So now let's see the working of LLMs. So now I'll be just showing you the architecture with respect to transformer. So the components of your transformer, if you see, always there will be an attention mechanism. You'll be having a feed forward layer. So how the training happens in terms of vast amount of data. So that's what I'm going to explain. So before knowing the LLM, why we need a vector representation? Why, how LLMs treat all these text? For us to understand how the language model works, we always need to know how it is being represented in terms of it. Suppose like I say cat means CAT, something like apple, I know APPLE. But how these language models, these large language models or any NLP models, how actually it interprets this text? Because language model uses large number of or large list of text, so it will always give a numerical representation for every word. So whenever it is a number being represented or used for representing a term, then we call it as a word vector. So now all the LLMs or any natural language processing model, whenever it uses vectors, then it means that it is utilizing a numerical representation for representing a term. Now let us just consider this example. This is English Wikipedia to represent the cat. So according to this corpus, it is having almost 300 words. Now to represent this cat, at least 300 number dimension. This is, let me just show you that. Now you can see this English corpus with respect to English Wikipedia. This is of 300 words because the entire vocabulary comprises of 300 terms. Now when I just check with the word frequency in terms of cat, so very close threshold I can set, or in terms of medium frequency I can set. So depends on how close the terms are. And here you can just adjust the similarity threshold. If I'm just keeping 5, then I can just relate it to more than 10 words, 15 words, like that. So now it is up to us how exactly we want the similarity to be assessed. Now the raw word vector of cat, if you see, so in this actually 100 rows are there and you can see 3 columns. So the representation is 300 dimension representation. So for cat, just a word cat to be understandable to the language models, we need to give a long list of numbers. That is nothing but the word vectors. These word vectors are depending on the corpus that we are considering. So here it is almost 300 dimension because 300 different words we are trying to correlate, and the correlation, it can be negative, positive, how exactly the embeddings are being represented. In that way, the numbers are being given. Why do I need this word vector? What is the use? Why it is useful in terms of considering a word as a vector? Why not it can be a term only? Suppose let us consider this example. So Washington, let us just take this analogy. So Washington DC is located at 38.9 degrees north and 77 degrees west. When we use a vector notation in such a way, similarly, New York, if you see 40.774, London 51.507, Paris 48, some numbers are there in terms of where it is being located. Now, from this, what we can infer is 38.9 and 40.7 is somewhat closer. 77 and 74 is closer. So I can say these two are relevant to each other, are related to each other. Now, these two, if you see, 0.1 and this is 74, there is no point, there is no way we can correlate these two. But here 51.5 and minus 2.40.1, somewhere we can say that these two are related to each other. So this spatial relationship will be easily extracted whenever it is a representation of a vector rather than just a raw term. So unless otherwise you know the term, you can't relate it, right? So now whenever it is a number, we can easily understand the spatial relationship. So this is the main difference between these two. And that is the reason why all the LLMs are being trained with the vector representation. Fine. Now, in the same way, any word, any complexity it can be, we can always tries to represent everything in terms of a vector. So this is how the word to vec model actually came into existence in the year 2013, and they tried finding out different possibilities, how the terms are being correlated. So always whenever they are finding the similarity, men and women being discussed in terms of same set of series. Similarly, whenever it is a king, then the term queen is being added. So likewise, they tried finding out the spatial relationship among different terms. It's not only always the spatial relationship we need to look for. Certain ambiguities will always be there whenever it comes in terms of natural languages. So how exactly term is used? Suppose let us consider the term bank. It can be either a financial institution or it can be a river bank. So according to the context, the bank gives its meaning. So we need to always avoid or ensure how the homonyms, we always call whenever a single term causes this ambiguity, we call this as a homonyms. So now we need to always ensure how to avoid this. Similarly, polysemy, the same word may not be a different context being used. It may be a same context, but how it is used always matters. So John picks up a magazine and Susan works for a magazine. Both are actually magazine. One is a physical entity where another one is an organization. So likewise, the two terms which is actually having a closely related meanings. It is complete bank, river bank, and the financial organization are completely two different extremes. But this magazine, if you see it, both are actually related, closely related term, but it infers multiple meanings. So likewise, many different ambiguities will be there. That also we need to take care whenever we are dealing with text. Now let us consider the GPT-3 model, because this is one of the open source model and we know the information about GPT-3. That's why I have added here. So totally GPT-3 has 96 layers. It is using a transformer. 96 layers of transformers are there. And now the dimension, if you see the word vectors it is using in terms of representation, is every single word utilizes 12,000. Now the cat dimension I have shown, right? 300 long, 300 dimensions. So now in terms of GPT, it is 12,288 dimensions for every word it trains with. So it is almost 20 times a larger model than this word to vec, which is being introduced in 2013. So what is there in this transformer? So every transformer will have two steps. One is the attention step and the other one is the feed forward step. This attention step will always look around what is happening in terms of how the sequence goes and all these. This feed forward step is the one which thinks about and actually gives the prediction in terms of the last word. So now this attention mechanism, if you see, it is mainly having three vectors. One is a query vector, other one is a key vector, then next final one is the value vector. Query vector is something where it describes its own in terms of what exactly every word, because in terms of query vector, we are going to make a checklist which describes the characteristics of the word it is actually looking for. In terms of query, what is the term? Is this term, what is the characteristic, what it is looking for? Whenever it is a key vector, it has its own checklist. So when you are taking a dot product, you'll be ending up with the value vector. Now, based on this context, so John wants his bank to cash the dash. Let's say, I don't know what it is next, but we are saying this. So now from this, who refers or what is this his refers to? Now we have to find it out. So this his is nothing but John's. So now this bank is nothing but financial institution because it is related to cash. So likewise, the inference that we are trying to find out. Now here the query vector for his, because from the context, John wants his, right? So this his, the characteristic, if you see, it is a noun describing a male person. So immediately the key vector in terms of this key vector will say John, because previous to this his, John was being quoted. So it describes about a male person. So we are trying to map his with John's. So this is how the attention mechanism actually works in terms of capturing the long range dependencies. So it is not only one particular attention mechanism we have, because always it is a multi-head attention mechanism. Every attention head will have its own task. One of the attention head you may see like it can match pronouns with nouns. Another can actually play around in terms of dealing with the homonyms, polysemies, whatever it is. Suppose, we have another attention in terms like there is a name like Joe Biden. It's not John to match up only one name. Joe Biden, let's say. Then this Joe is not a separate person. Biden is not a separate person. These two words are together as one single phrase in terms of Joe Biden. For that, we'll be having another attention head. So likewise, several attention heads are there, and each of the head will definitely have its own task to be done. So now in the real world scenario, there is a team from Redwood. So they actually try to understand how this GPT-2 works, the predecessor of GPT-3. So they tried understanding how actually the prediction happens. So they gave a query. When Mary and John went to the store, John gave a drink too. So they want what could be the next word predicted by this GPT-2. So immediately the GPT-2 says the term as Mary. They want to know how it says Mary, because in the context we have Mary as well as John. But why it says Mary, why not it is John? And then the researchers actually identified three interesting attention heads in this model. So the three attention heads called name, three types are there, but in that three type, the first type is name mover head. In terms of name mover, they placed three attention heads. So the name mover heads is something which actually focuses on copying the names. Uh, whenever it is a specific token or names to be copied, this name mover heads will always help or focus in terms of name to be copied. Now the copied information from the Mary vector, because it copies the information from the Mary vector to the final input vector. But how it decides Mary could be the right word, because name mover always focuses on which name, copying the name. But how it decides Mary to be copied, why not it is John? There were the second type of attention head, that is called as subject inhibition head. Four attention heads of subject inhibition heads were there in the GPT-2. This head always blocks the irrelevant or redundant information being copied. So this subject inhibition head mark the second John vector, in the context. This is one, this is two. Two different names are there. And this is the second repetition of the John, second token John. So now that mark the second vector, second John vector in a way being copied by the name mover. So it blocks the name mover by say copying the second John. How it knows this is a second time John? We have a one more head which is called as duplicate token head. So it numbers. So this is token 1 and this is token 2 and this is the repetition of token 2. So this duplicate token head actually numbers it. So this, when you see that, so it can't be because already John and John is together. So there is a replication already. So this can't be replicated again and it could be Mary. So this is how the Redwood research team just went back. They tried trace back and then they found out this is how it works. And now after that from GPT-3, GPT 3.5 and all these, we have the reasoning part. But before that, we don't have. Actually, GPT-2 generates the results, but we don't know why it is giving so and so results. And there is no explainable part in that. So totally these 9 heads actually made this task to successfully copy the name Mary at the prediction. So now we have the models in sequence. So GPT 3.5, GPT 4 are actually complex and it is being inbuilt with the reasoning also. It states its own reason why so and so prediction or why so and so generation is being done. Now, what is the role of this feed forward network? Because, attention head always look behind. So look around, what are the different terms, how many times Mary is being used, how many times John is being used, which to be copied, which not to be copied, all these things. Now, after all these attention heads transfers the information to the feed forward neural networks. It will think about each of the word vector and then tries to predict the next word. Now, once the attention had transferred the information to the feed forward, there is no more information is being exchanged between the words. Because feed forward, it's a separate layer which does everything in isolation. Now, but for feed forward layer, definitely it have the access or information being accessed from the previously copied attention head. From there it starts. Now, as I told you in the beginning, the input vector, the dimension is 12,288 values for every vector. So similarly, the output will also be the same number of values that we are going to get. So in between the hidden neurons, if you see, it is 49,152 neurons are there in the GPT-3 architecture. So input neurons, hidden neurons, and output neurons, all these are 12,288. Now the billion parameter, million parameter we are saying, right? How actually this we are saying these many parameters being trained with, or these many parameters the model learned with, how we are saying that. Now for each hidden neurons, totally we have 49,152 neurons. For each 49,152 neurons, whenever it is a fully connected network, each neuron will have access to all the 12,288 input values. Similarly, now all the output neurons is also being connected with this hidden neuron. So when you say each feed forward layer, 49,152 into 12,288, similarly 12,288 into 49,152. So we'll be getting almost 1.2 billion weight. And in the very beginning itself, I told you there are 96 layers in the transformer. So obviously 96 feed forward layers will be there. So in this case, if one feed forward layer contributes or learns in terms of 1.2 billion, then 96 layers will learn up to 116 billion parameters. So the total GPT's weight itself 175. Remaining 49 may be just contributed by the attention mechanism, but rest 116 is being contributed in terms of feed-forward neural network. So this is the architecture and the working of the LLMs. So always in terms of transformer model, we'll be having the transformer with attention and then feed-forward layer. From there, we actually come up in terms of encoding and decoding. So the research products that I'm working on, so almost 1.5 decade, I'm just working in terms of sign language recognition. So I'm very curious how this LLMs and GANs can be inbuilt in terms of this tool. So this sign language recognition, if you see, it is mainly used by people with hearing impairment or speech impairment. So they'll be using this as a communication medium. So they'll be using the actions or the gestures in terms of communication rather than speaking and writing. So, in terms of India, if you see the statistics, the top 10 countries, India is the one which is having the leading number of this deaf mute population. So I feel like so this is one of the innovative solution that can be bring in. So now this particular proposed Signcraft tool has the ability in terms of translating. That is, suppose you are just giving your text, it has the ability to translate that in terms of another language. And whenever you are giving the text, it has the ability to generate the gestures. So this could be the first front end tool which has both the options. So I tried implementing recognition. That is, whenever you're showing the actions, it tries interpreting what action you showed. Second thing is translating in terms of either you can speech or you can just type, whatever it is, it can tries to mimic and understand in terms of either recognition or generation. Third thing is a generation part. That is, whenever you are typing as a text or speaking as an audio, it has the ability to synthesize the sign poses or in terms of videos. Why? Because based on all the surveys and researches, so I feel like these are the existing challenges in this particular domain. One thing is there is no dynamic gesture recognition and including non-manual and manual features. Second thing is in terms of how to understand this contextual adaptation, how the semantic level understanding can be there. Then in terms of generation wise, many generation tools are there, but it is either based on some animated avatars or in terms of the skeletal poses. It is not so realistic. I just tried building a tool, whoever does the action. The communication also in the back, the real face of the person, whoever is communicating, in the same way, we tried replicating the actions in terms of sign gestures. So with respect to available data set, Indian Sign Language data set is very minimal. So the main contribution of this Signcraft is because this is based on LLMs and GANs, as I mentioned, the architecture is actually complex, but still, when it comes in terms of GAN, I tried optimize it with the help of unit architecture. So with both upsampling and downsampling together in the same architecture, you can see I just made it parallel. So the generation and discrimination, when it happens in terms of parallel with the ground truth, the complexity of the model is bit reduced. So that's why this is being added here. So that is one of the novelty that is being bring in here. Apart from that, certain metrics are being introduced. So how we can align this textual and visual score, and then how we can improvise the performance in terms of gloss to gesture synthesize and all these. So here mainly three modules are there. One is text to gloss, that is natural text. But in terms of natural text, suppose I say like I want to drink water. But when it comes in terms of sign language, there is no point in saying like to, uh, have, has. So all these grammatical part won't have any weightage in that. So we'll be considering only the gloss. So that is the first thing. Second thing is gloss to gesture synthesize. That is from the glosses, the sign glosses, how the action is being synthesized in terms of DF GAN unit. Then optimization procedure. So this is the overall architecture. And you can see the left side is the one. Actually, we tried coming up in terms of skeletal poses. The problem is it is creating the same posture being done by the user, but the problem is it's not so expressive and the animations, the hands actions are not so clear. But in the next image, you can see it is just with DF GAN, not with respect to the other attention and everything. So now we are getting a more clear and visual effect. So these are the comparative study. Maybe I can just skip this and I'll show directly this.
Hello.
Yes.
मैंने आपको mention कह रहा है
Sorry. All right. So this is one of the industry product that we have developed. So this is again built on the basis of generative AI model. It helps in terms of training the employees in the organization. There is no point like every time a manager needs to sit and listen to the problem of how the employee faces. Instead, the training session can be completely given by the generative AI. Randomly, it creates some questions and it wants the employee to interact in the platform. So accordingly, the questions, how it is being asked and what exactly the response from the employee. So based on that, the competency score is being calculated and the training, how he attained or he or she, whatever it is, whomsoever it is. So how they have attained the competency that we can actually come across with the help of this particular tool. This is one of the tool which we have developed for trajectory solutions and we delivered it. Now it is in action there. So the other tool is a grade scale. So this is being introduced. Now, we have a Google form which does the evaluation in terms of objectives or fill in the blanks, everything. But when it comes in terms of essay-based questions, then there is no any solution available in terms of bringing out the proper solution. So now we have customized this for operating systems first chapter. So here people can take up the questions and whenever the answers are being uploaded by the students, so it actually understands several parameters like grammar, vocabulary, how the response is being generated, all these things. So I'll be just quickly dragging this. So I'll be creating a module like elements. Once the student submitted the assignment or any question or anything, now as a teacher, now the student is attempting the question. As a teacher, you can just sign up and you can actually check how it is being done. And finally, the report will be generated like this. So you can see for the first component, this is what the report is. So we can say question number one, how much he scored or she scored. So now we can see there is an accuracy level, GPV level, everything it is being assessed and it is giving the relevance. So the final grade is 7.07. So it depends on maximum and minimum weightage that we are setting. So what exactly the response the students are going to give. Accordingly, the essay-based question will also be evaluated. So these are the two industrial products that we developed and we delivered. So I have covered the basic foundational skills in terms of GANs, LLMs, and how the working of GANs and LLMs, and several the research vertical that I'm working with, and the other industry products that I have delivered. Thank you. If you have any queries, you can go ahead.
Anyone have any questions? They can please share their questions in the chat box, or can answer their questions through this through unmuting yourself. I guess there are no more questions, ma'am. Yeah.
Fine
Okay.
then.
Okay. Thank you
Thanks for
so
the
much, ma'am.
opportunity.
Thank you so much. It was really a very great session. Generative AI is present and future for all the students and the people who are learning artificial intelligence and about the technology today. So I'm sure that it was very helpful session. You also showed us your websites. We all really appreciate your efforts today here, ma'am. And we wish to collaborate with you again in the future for your knowledge. We hope you share it with us again if in future we
Sure.
get chance to do the session again. Thank you so much, ma'am.
Definitely.
Thank you
Thank you.
so
Thank you.
much.
Madam, myself, Dr.
Thank you, ma'am.
Vengatesh. Hello.
Yes,
Yes.
sir, you're audible.
Yes, madam. Thank you for madam for accepting invitation and again, so giving the excellent session. Really, our students, it will be eye-opening session for them. So and again, they will definitely they will understand. They will work on those domain and technology. All students from the first year and second year only. So this
Okay.
session will be very helpful for them in future. And again, where they need to focus in maybe in upcoming days. Okay. So thank you once again on behalf of Sanjivani University. Finessefleet for accepting our invitation to give an excellent session.
Thank you. Thank you so much.
Thank you. Sir, you want to give something?
Thank you, ma'am, for your like good keynote session. It was great, and hopefully it will be helping all the students and they can apply in real lives and all. Thank you, ma'am.
Thank you. Thank you then.
Okay, so let us move forward with our today's presenters and the presentations. Before starting the presentations, I would like to introduce our jury members for today. Miss Usha Sharma from NIT Arunachal Pradesh and Professor Rajesh from Arupadai Vedu Institute of Technology, Chennai, India. We welcome you both today here. And now let's move forward with our first presenter. Our first presenter for today is Saumik Chakraborty. Are you here, Saumik Chakraborty?
Yes, ma'am.
Yeah, you can start your presentation by sharing your screen.
I have shared the screen of the PPT. It
Yeah,
is
it is
visible.
visible. You can start.
Good evening. I am Soumik Chakravarti from NIST University, and today I am here to present about my project Lingua Bridge. Lingua Bridge is a AI multilingual translation for Indian and regional languages like Hindi, English, Oriya, Bengali, Tamil, Telugu, many more. This Lingua Bridge is the project which is target to bridge the gap between the language gap, as in many of us don't understand many languages out as well as any ancient languages like Sanskrit and many more. So this is the project which covers the gap between these between languages. This model supports over 22 Indian regional language and more procedure. Presently, many models are present like Google Translator, AI for Bharat, Text Blob. But how this model is different? These models compares these existing models and also takes unsupervised learning and compares this model by taking the best results. As in Google Translator is based in is best in translating English, Hindi, or Oriya language, but it is weak in Sanskrit, Dongri, or Manipali language, which has a great advantage in for Bharat. And sentimental analysis is done by text block. So by comparing these uh, accuracies, the best accurate answer for the model is selected. Like in for translating English to Hindi, the model is switching to Google Translate. It is using random forest and decision trees for this method. I have referred to some of the research papers like Rutherford research paper, which was in 40th International Conference of Machine Learning for the reverse speech recognition, and Blogate's S.L. Green's research papers, which was for the case study for African American English, that is the translation models. Then coming towards the methodologies. What is the methodology? Methodologies are the JSON-based custom dataset. That is JSON files. Many JSON files are used for the efficient translation. This JSON file contains the key and dictionary, the translation from one language to another. And this way, many 22 or plus languages are listed. This some of the engines like the translator libraries based on Google Translator for real-time translation, and also AI for Bharat Indic library. For sentimental analysis, it probably uses text block, which analyzes the sentiments and then converts it to a proper output. For the visualization, I've used Matplotlib and Seaborn, which is used for plot model accuracies and confusion metrics. Now coming towards the UI part, I have used a basic Streamlit web app for which consists in my web app. There are four modules. That is chatbot translator. In this chatbot translator, it uses random forest and it can also convert from TTS to SST, that is speech to text, and text where it can converse with the user. Means it does not converse, it just translates the user's input to the language users want to. Then comes the text translator for the only for the texting purpose. If the user only wants to text and understand what is the translate of that particular thing, then this can be used for sentimental analysis and accuracy insights. Now coming towards the accuracy insights, these are the accuracy insights wherein the accuracy of Google Translator, as it supports more than 50 language, so it has the accuracy of 90%. And text blob is used for mainly the sentimental analysis, so it has accuracy of 85%. Lingua Bridge supports sentimental analysis and translation through sentimental analysis, and it is prepared in a low computing, so it has accuracy of 1%, which is mostly nearer by for Bharat, which is a high-tech model, uses around 20, 10 to 15 models and many language data sets, so it has more accuracy. And this lingua is almost reaching towards its accuracy by time. Now, these are some of the languages and their accuracies. The average accuracy is mostly 85%, where Hindi has a maximum accuracy of 90. Um, some of the languages like Bengali, Gujarati, Hindi, and many more. Now, this is the confusion matrix where I have listed for the major five languages like Hindi, Bengali, Tamil, Telugu, and Marathi, where Marathi is seen as the most best language, and more like it has a very and very well patterned confusion matrix. Coming towards the key findings and challenges. Key findings are it can successfully translate the international languages to other languages, mostly the Indian, mostly all the languages other than the language, with high accuracies and by sentimental analysis. Challenges were variability in sentiment detection. That is, in most of the languages, sentence can be same, but the pattern or the sentiment can be different. Like "I am tired" is a very neutral sentence when it is spoken, but it differs from user to user. When the user is basically very tired, and by analyzing the text by using NLP, these can be done. And API dependency, as I have used Google Translator as one of the best open source model. So the API, it is API dependent and it has some of the limits. Now, I would like to conclude that these projects a multilingual translation with a code mix detection. Here, the project also going to support some languages like English, Bangladesh, Tamil is a mixture of Hindi and English. That is, the text can be in English, but in the reading pattern, it can be in Hindi. And it supports over 22 plus regional Indian regional languages. Can be used in education purposes, customer support, government services, social media, journalism, content moderation, and many more. because to fulfill the gap between the languages, it can be used anywhere in business or anywhere. Now, these are the reference paper that I've used. That is the self-supervised learning of Y. Mohammed and Auli. And these are many more research papers I have searched to make this project. Thank you.
Okay, that was nice. Can I take a look on the confusion matrix once?
Okay, just
Okay, so confusion matrix for the language translation, you have predicted levels. So my question to you is, are you uh, using the confusion matrix and accuracy for quality check, or what exactly you are using this matrix for? Can you take me to the previous slide? Okay, prior to this, next previous slide, please. Okay,
is it this one?
so yeah, I would like to understand whether usually for text translation accuracy, we don't consider accuracy there. There are some other metrics that we have used. Have we explored that? Like
Probably yes.
BERT BERT, and I think there is some other comet. All these are there. Have you explored those metrics?
No, currently I was exploring only the accuracy and the confusion metrics because these
Uh-huh.
are the basic ones. For I am in this project will be extended more forward. So thank you for the suggestion also because I was not having the basic more idea about the birth, but
Yeah, what just no, no, I've not completed. What I'm trying to understand is in your project there are two aspects. One is the linguistic aspect, which is the translation, how well the model is translating. Okay, because I think you have mentioned you're translating it from one language to another, English to Bengali, English to Odia, Odia to English, or something like that, right? That's what you're doing.
yes,
Yeah.
yes,
So that is one aspect. Okay. And for that, please consider these other metrics which I mentioned. Just try and see, okay? Like BERT, COMET, COMET, and all these are there. Please explore that. And if you're going for sentiment analysis from the text, like you had somewhere mentioned about positive, negative, and neutral, right? So if you
yes,
are trying to figure out whether how well the model is classifying the sentiments, and there if you're using for accuracy as an evaluation metric, that is correct. I feel that according to me, okay, what I have gone through in NLP. But please look into if you're using some models like this, whether accuracy alone can be considered as an evaluation metric or not. Please check that, okay? Especially in the translation aspect. Hmm?
yes, ma'am.
Yeah. I'm done. Any other questions if anybody has?
Rajesh sir, do you have any questions? Should we move forward?
No, no, I don't have any questions. Can move forward.
Okay, then. Thank you so much, Soumik. Let's move forward with our next presenter. Uh, yes. Okay, so the next presenter is Harik. Are you here, Harik?
Harika.
Yes, ma'am, I'm
Okay,
here.
sorry, Harika. Yeah,
Yeah, I'm here.
please start presenting.
Yeah, yes, ma'am, I'm here. my screen visible? Hello?
Yes, it is, Harika.
Yeah, okay. Am I audible? So, ma'am?
Yes, yes.
Yeah, okay. Thank you. Good evening to all the respected judges and audience members. I'm Harika from Team Excalibur, and today I'm thrilled to present my paper, Micro Learning Recommendation System, in which our goal is to transform online education, making learning more efficient, engaging, and personalized one. We are the team from third year CSC from Aripada Video Institute of Technology, and our mentor is Dr. Balakrishnan S. Sir. He is guiding us throughout this project, ensuring that we build something impactful and innovative. Let us begin with the abstract. As we know that online learning is growing day by day, and we as a student struggles a lot with long and overwhelming videos. Just
Adhikari, if you are sharing your screen, we are not able to see your research paper. Can you please switch your tab?
yeah, yeah. One second. Is it visible now?
Yeah, it is. You can.
Yeah, okay. So, okay. As we know that online learning is growing day by day, and we as a student struggles a lot with long and overwhelming videos. We just skip through them, like looking for key points or some high valued content. It's not only us; 80% of learners do the same. They also do, just they skip the long videos just to find the key contents. This leads to cognitive overload, disengagement, and ineffective learning. So our solution for this is very simple. We are going to build a micro learning recommendation system, which aims to recommend brief and skill focused learning videos that will be under 15 minutes, and we are going to extract the high value content from long videos, ensuring that learners will only get the most important information. um, um, yeah. I'm going to compare with existing system and our system. Like we all use platforms like YouTube, Coursera, Udemy. These platforms, just they are not built for effective learning, because they just focus on delivering the content rather than optimizing it. And this is where our system comes in. Like when it comes to video length, existing platforms, the video length is very long and overwhelming. It is about 30 plus minutes, but ours will be short and focused. It will be under 15 minutes. When it comes to personalization, existing systems uh, suggest videos based on popularity and watch history, but ours will be based on skill level, learning styles, and career goals. When it comes to content extraction, in existing systems, we manually skip and search the content that is required to us. But in our system, we are adding filtration and summarization technique that will extract automatically the key content. And in existing system, engagement is very low, because there is a lot of content which leads to disengagement and ineffective learning. But in our system, it is very high, because we are targeting recommendations, like we are giving suggesting recommendations based on the learning style of the user and their skill level. When it comes to learning efficiency, in existing platforms, learners struggle to find relevant content to them. But in our city, we are giving a smart recommendation system. Like in minimum time, we are giving maximum retention. And yeah, we have identified some issues. Like there are many online courses and educational videos online, but still learner struggles to find the right content. This is because the current system, they just suggest videos based on watch history and popularity, and also the existing systems are built for content delivery rather than content optimization, and there is no filtration and summarization of long videos. So that is the gap we are filling here. We have identified some issues, that is again existing systems, they there is no existing system they effectively filters or summarizes the videos, and uh, we as a learners, we struggles to find high quality and short and relevant videos that is relevant to us for skill development. And again, existing recommendation systems, they suggest based on popularity. Then there is a lack of AI driven techniques for extracting important information from lengthy lessons. So our objective is to empower learner with smart and time efficient education. We have only two key innovations. The first one is we are going to recommend short and high quality learning videos based on skills, career goals and preferences. And the next one is we are using AI, NLP and deep learning to extract key from long videos, ensuring learners get only the most important information. Just like example, let us say a student wants to learn a Python programming. Instead of watching a 2-hour tutorial, our system will find the best and most relevant 10 to 15-minute videos that will explain what they actually need. So this reduces the time wastage, and also there will not be any unnecessary content. Then uh, so we are currently in data scraping stage. Just to give a clear overview, we have created a flow chart that explains the entire implementation process from data collection to recommendation generation. The first, we are going to scrap the data from three sites, that is YouTube, Udemy and Coursera, in which we are taking three data sets, that is user interaction, skills and Coursera, courses data set. In user interaction, we are going to scrap data of watch history, likes, skips and watch times and video engagement metrics. Then when it comes to skills, we are going to extract scrap data, that is skill name and skill category and difficulty level. And in courses, we are going to scrape data like a video title from and description, thumbnail, durations and view ratings. Then the next is data pre-processing and storage. Here we are will clean and structure data for further processing. We are using NLP for cleaning the text, that is NLP toolkit, and SQL for storing the processed data in database, and pandas and NumPy for data cleaning and transformation. Then then the next step is content summarization, which means we are extracting high valued content, as I said, from long videos. In this, we are converting speech to text using Google speech to text, and summarize transcripts using GPT based models that will help us to regenerate or rewrite the shortest version by extracting the summarizing the transcripts. Then again, we are extracting important keywords by using named entity recognition. Then the next step is recommendation system. This is quite challenging for us as we are using machine learning and deep learning. Yeah. In this, will suggest personalized and high quality learning videos. We are using algorithms, that is machine learning algorithms, collaborative filtering, in which we are using user based collaborative filtering and item based collaborative filtering. User based for finding similar learners, and item based for finding the similar videos. Then also hybrid model, like no content based filtering, that is NLP and ML, that is algorithms we are using here is TF, that is term frequency and inverse document frequency, just to extract the important keywords. And hybrid model, like we are combining here deep learning and machine learning just to improve the accuracy. And deep learning, we are using neural networks, that is recurrent neural network and deep learning neural network, just to improve accuracy and analyze the learning behavior over the time. And then at last, we'll just create a user interface and deploy it. We will create a user-friendly platform for AI-driven learning, in which we are going to create a web app to display the short videos, and we are going to implement a search feature for personalized learning paths and deploy our system using cloud like AWS. Um, At last, I would like to draw a conclusion by saying that our system makes learning faster, better, and more effective. Students will spend less time in searching and more time in learning. That is what actually matters. And also, yeah, and also we are not just recommending videos. We are here to transform the way students learn. Our system ensures that every learner gets the best content in shortest time possible, tailored to their needs, which makes learning more effective by selecting the right content at right time in a right way. These are the references, and thank you. I would like to hear the questions.
Okay, so very nice presentation. I would like to see the practical implementation. Do you have it with you right now?
No, ma'am. Currently, we are in data scrapping stage, ma'am. So just that's why I mentioned here whole implementation how we are going to do.
Okay, so which stage you are right now in? Data
In
scrapping.
scraping, yeah, data scrapping. Yes,
The
ma'am.
first one, that is data. Okay.
Collection stage, yeah.
Uh-huh. So what
Yes,
are the
ma'am.
problems that you're facing in the collection?
Yeah.
And what are the sources that you have taken into consideration? You've mentioned here Coursera, LinkedIn, and all.
Yeah. We are still in scrapping YouTube data, ma'am. That too, we have started 2 days before only scrapping. Um, the problem we faced after it, yeah, we not got the clean data. For that, it is quite challenging for us because it takes lot time to go on to further implementation, ma'am.
Mm-hmm.
Yeah.
So this entire workflow which you have mentioned here, the
Yes,
model,
ma'am.
the block diagram, have you, I mean, on what basis have you come up with this block diagram?
We have discussed, ma'am. We have a team of 4 members. We have discussed someone. I mean, everyone is expert in some field, so they have gone through each algorithms, which is perfect for our recommendation system. Through this, we have decided to do that.
Okay, so
Yeah.
because you mentioned about ML, you're going to use, and the second last step you mentioned that you're going to use ML and DL. So here, uh,
Yeah.
what specifically which model you're going to use? You can go for lighter version of the DL models. Okay, you can also
Okay.
use Hugging Face. Okay, that is also one area which you can, as a student, you don't have to go deeper into creating the models. There are existing models which you can use using Hugging Face. That will
Okay,
be
ma'am.
my suggestion to you. Okay.
Yeah. Thank you. Thank you, ma'am.
Yeah.
Thank you for your suggestion.
Yeah, that's from my side.
Yeah.
Uh, sir, do you have any other questions? Hello, Rajesh sir. Okay, I guess sir has no question. Let's move forward with our next presentation. Thank you so much, Harika.
Thank you. Thank you, ma'am.
Let's call our next presenter, Pujitha. Are you here, Pujitha?
Yes, ma'am.
Yeah, please start presenting. Are you able to share your screen, Pujitha?
Yes, ma'am. Some functional issue, ma'am.
Okay.
Wait, ma'am. Can you wait 4 minutes, ma'am?
Hi, Shaley. I think we can go next. Meanwhile, Pujita to prepare her presentation.
Okay, so let's move forward with Murari. Hello, Murari, are you here? Hello. Pujita, are you ready with your presentation?
पूछो मैम को
Ma'am, can you move to the next participant? I will be getting you very shortly.
Okay, then. Murari, I guess that person is also not here. Let's move forward with Dhanushwari. Dhanushwari, are you here? Maruti,
Yes, I'm here.
Abheraj. Acha, okay. Maruti, are you here?
Yes, I'm present.
Yeah. You can start presenting. Share your screen.
Okay. Okay, let me share. Okay, my screen is visible.
Yes.
Okay. So, good evening, everyone. I am Maruti Nimbargar, a second year student from AIDS department at Sanjivani University, and I am here today to present on the topic Study Swap, a campus marketplace. Okay. I'm here to discuss an issue that every student has faced at the same point, the challenge of acquiring and managing essential study materials like notebooks and other stationery items. In college, we rely heavily on these materials of our daily academic activities, but not everyone has equal access to them. Some students struggle to supply their needs, while others often end up with extra or unused items that go to waste. This creates an imbalance where students have more than they need while others lack basic resources. So, to solve this problem, we propose a study swap, a centralized platform that enables students to exchange, donate, or acquire study materials efficiently. So, instead of buying new stationery item, every students can share and repurpose items they no longer need, making education more accessible and affordable for everyone. Beyond just saving money, the initiative promotes sustainability by reducing waste and encouraging the reuse of resources. Imagine how much paper, notebooks, and other supplies we could save if we had easy way to share them. Additionally, it fosters a sense of community where students help each other by ensuring that no one is left struggling for basic academics needs. So these are the some of the features of our applications or projects. You can say search and filter options where student can easily search for specific stationery items like pens, calculators, or art supplies. Chat and negotiation. User can chat directly with the person offering the stationery to ask about the items, conditions, availability, or exchange terms. Location-based listings. The platform can show available items near the user's location, making it easier for students to pick up or exchange stationery without traveling far. Next, borrowing feature. Some students might need an item for the short time, like scientific calculator, drafter, or a reference book for an example. This feature allows user to borrow stationery for a limited time instead of permanently exchanging or buying it. Community discussion forum, a space where student can ask for recommendation, discuss study tips, or request stationary items. For the result, the study swap, a campus marketplace, helps students easily find and manage stationery without spending too much money. With options like search and filter options, students could quickly find study materials. This platform also allowed students to trade, borrow, or get stationery for free, making it more convenient and cost effective. This made the campus more eco-friendly by encouraging the reuse of the materials instead of buying new ones all the time. So helping students get stationery easily, saving money, reducing waste and promote sustainability, growth and future plans. Many students will start using the platform actively, showing its success. In future, Study Swap could expand beyond stationery to include books, lab equipments, and project materials, making it even more helpful. For the conclusion, we can say that uh, the platform helps students by making it easier and cheaper to get the stationery they need. It allows to share, trade, and donate items. By promoting teamwork and sharing platform, make it easier for students to get their supplies and help manage resources better. It aims to create a more affordable and convenient way for students to access what they need for the resources. Thank you.
Okay. So Marathi, how far have you implemented the project?
No, ma'am, we have not implemented yet. We have just proposed an idea, and soon we will start implementing it.
And what are the technologies that you are planning to use for this project? The
We are using
softwares,
Flutter. Yes, ma'am.
Flutter, okay.
Flutter for UI. Backend, we are using Supabase and Postgres SQL for databases,
Okay.
and also
Okay.
Google Firebase.
Fine. If you just go to the following slide, just move to the next slide where you have mentioned about the features. Yeah, this one. So search and filter option, it's easily possible. And how are you going to include the chat option? Are you using any chat bot or something like that?
Ma'am, means we can add the chat options if I am uh, making the product available. So the one who needs it, he can chat with me. If I can give it directly to the person, or I can trade it or borrow him. For that purpose, we are using chat and negotiation.
Okay, so which means these are the methods in which you can conduct uh, uh, the project that you have.
Yes.
Or these are the features that you will have in the project in your
Yes, ma'am.
model.
Yes.
Which one is it? Are you going to have all these features in your project?
Ma'am, the search and filter option, also borrowing features, and also stationary exchange platform, that is definitely will be there in our project. And
Uh-huh.
also in future, we will try adding more features
So my
that will be
question
helpful
about
for
the
the
second
students.
point is chat and negotiation. Are you also putting this as a feature in your model?
Yes, ma'am, we will try to implement it.
Then what have you thought for that? Are you going to use a chat bot, or how are you going to implement the chat feature?
Uh, Not yet discussed with my team, but I'm
Okay.
having a skillful teammates, so we will
Huh.
figure out that.
Yeah. So why my question there was just because then when you are going to have a chat bot, definitely there will be an AI integration. So that was one area where I was trying to understand how you're going to do that. Also in community discussion forum, of course, here people will be participating, and so that's okay. Uh, but that's where, again, when you talk about location-based listing, are you going to use any, what is the idea about location-based listing?
Location-based listing means, as we know, every university or colleges have their own email IDs. So for their campus, in our application, in our projects, we log in through our college email ID. So it will be helpful for the student to locate or search the items they need in their nearby areas.
Okay, these items means what are the items you are focusing on? What are the
We are
items that
focused
you'll be
on the
catering? Mm.
like stationary items, question papers, last year question papers. Also, many of the students need a drafter, also drapery system we are going to add. And also, if anyone needed any web developer to teach them or something.
Okay, I get it now. So which means in location-based system listing also you'll be using some GPS system or geolocation to figure out, right? That aspect also has to be considered, isn't it?
Yes.
So the idea is okay, but you need to do a little more grooming and a little bit more of brainstorming with your team, and please sit with your mentor. You can actually come up with a product with this. Okay, if you can do it, if you are successfully implementing it. Okay, fine.
Okay.
Yeah.
Thank you, ma'am.
Rajesh sir, if you have any questions, you can go ahead.
No, I don't have.
Okay, then I guess we can move forward. Pujita, are you ready?
Yes, ma'am.
Yeah, so you can start your presentation. Pujita, if you want some more time, you can please.
Sorry for the inconvenience, ma'am.
Yeah, okay, no problem.
A very warm good evening to one and all. This is Pujita. I and we Danish Kumar. We are from AVIT and we are here to present our project, that is AI agent for board games. So this basically provides how an AI enhances and play game and teaches you the strategy. Before moving to the project, let me explain you the gaming market strategies. This will be highlighting the industry growth. The gaming industry is growing at of about 25% annually. The projected of around $20 billion revenue by 2025. AI is a game challenger in this space. Gaming in the industry is experiencing an unpredictable growth with billions of players and the massive revenue. It's a dynamic market. AI enhances the gaming skills through the personalized feedbacks, and the gamer gain and deeper understanding of the game strategies. Moving to the next part, AI for the skill improvement. Now, why we should involve AI in the gaming part? Because it provides you an personalized training. AI adopts and say you the weak points. It helps you to adjust your skill levels. It provides you with the data driver insights to improve your decision making. So this basically shows how an AI enhances your skills. Now, how does an AI does this? AI uses AI uses the Q learning process, which is an reinforcement learning and machine learning. It uses the minimax and alpha beta algorithm, which is used for the strategic decision making. It uses Carlo tree search, which is used for the probabilistic AI moves, and the different Python libraries, which involves the NumPy, Thinker, Random, and Pickle. Now, how does it work? It works by the two parts, that is the AI opponent, which will be challenging the human players, and the second one is adaptive players, which will dynamically adjust the skill levels. AI potential in gaming. So these are the libraries that we will be using in our project. AI potential. So the future game possibilities. It will be using the the more contents, like for the expansion of the packs. We will be using the new game nodes, that are the strategies, the different types of the strategies. and the personalized AI, that are the player experiences. The real world use cases involves training, skill development, competitive plays, which involves the advanced AI opponent, the game designs, the enhancement, uh, the places where we can apply this, and the enhancement for this are for the dynamic scenario where the changing game narratives, then the adaptive rules, and for the regulation and for the regular updates. Before ending up the presentation, I would like to show you a short demo. So this is the code, and so this is the code for the tic-tac-toe. So and here we get all the logs. These are the logs. So that's all. Thank you.
Okay, Pujita, just go to the slide, to the first slide. Hello, Pujita. Yeah.
Yes.
Just a minute. Please share once again. The second slide, sorry. Yeah, so you have given us statistics about the gaming market, but
Yes.
this chart is not clearly visible.
Yes.
Have you noticed that before the presentation?
Yes, ma'am. Now only we noticed.
Yeah, so please see that, at least what you're presenting, that is in a proper presentation mode with the proper color combination. Okay. And then please move to slide number 4. Yeah, so here you are mentioning about the algorithms and Python libraries that you will be using. So why are you using decision tree? Can you tell me?
Sir. Ma'am, we are not using decision tree, ma'am. We are using queue learning, ma'am. That will save the queue tables and queue values, and it will act according to what we move, our next move.
Okay, then why is this slide talking about the decision tree pruning and all that?
Ma'am, we will going to enhance in the future, ma'am. If we build it
Okay.
more in large scale, it will be useful, ma'am.
Okay, and then this flow chart, is it drawn? Because I didn't understand what is this text inside, like AI, something is written, then is it a spelling mistake or something like that? In the
Where, ma'am?
slide, in the diagram here, the flow diagram, I was not able to follow this flow diagram. Can you explain me? Is it a
Ma'am,
flow? Please tell me.
ma'am, it's AI generated PPT, ma'am. So
Okay, I get it. Fine. So that's why I got a little confused,
yes,
because
yes,
here
ma'am,
you're
yes, ma'am.
mentioning about
We just
uh,
didn't refer any of that. We just focused on the code and output, ma'am. So we work on that.
please check your slides before you come for presentation next time.
Okay,
Okay,
ma'am. Okay,
because
ma'am.
this creates a confusion, no? Because I was thinking that what maybe I have not understood this flow chart, and you're trying to present something here.
Ma'am, you have any of the doubt, you can ask me, ma'am. I will clear you all. I will show you the code and I will tell you whatever that is, ma'am. If you ask
Yeah.
any.
Yeah, I'll come to that because this flow chart, the PPT part, whatever was mentioned, these two charts, I had some doubt. Now, what you have considered the tic-tac-toe? That's one game which you have considered. What are the other gaming platform games you are going to consider
Ma'am,
in future?
tic-tac-toe is a simple and minimized game, ma'am, so that it's easy to make uh, and if we make any agent, it is easy to train to also, ma'am.
Yeah,
But in
yeah.
large game like chess and checkers, we need large data sets and more number of computing power.
Yes, yes, yes.
So we work on
So how
tic-tac-toe
are
only.
you going to, that's what is my question. How are you, because when the amount of data set increases and the platform also gets heavier, have you thought on what are the, how are you going to work on your system?
Yeah,
Maybe,
work on our system means we should be increasing our computing power. Like we should use cloud computing like that.
yeah, yeah, that's what I was just
So
trying to.
there were two columns, first name and last name. Now we have merged both the columns into a single column named full name, and you can see the first name, space, and the last name. Now let me give
Yes,
the sales call.
Pranjal, please mute yourself. Yeah, so that's what I was just trying to understand, because when you go for development of the of a little more advanced level of gaming, you will
Yes,
need
ma'am.
more resources. Okay, and the
Yes,
computational
ma'am.
complexity will increase. So
Yes,
please
ma'am.
go ahead with the cloud computing. You can also try amalgamation of both edge computing and cloud computing.
Yes,
Okay,
ma'am.
so that you can try. Yeah.
Yes, ma'am.
So implementation part, the as per your plan, you have just done a dry run on the tic-tac-toe, but actual project is yet to be implemented, right?
Yes, ma'am. It's
Okay.
we thought it for chess game, ma'am. Chess is the
Hmm.
all over world game, so tic-tac-toe
Hmm.
is not a simple game for computer. So that's why
Hmm.
we make that.
Okay, okay, that's you are on the right path. Please continue. That's a good idea.
Yes,
And
ma'am.
make sure that your presentations are up to the mark. It should not confuse the
Yes, ma'am.
audience.
Yes,
Okay.
ma'am.
Yeah.
Sorry, ma'am.
All right.
Sorry, ma'am, for
Yeah.
that.
Fine.
If
Yes.
anyone has any
Any other question, ma'am?
questions, you can ask. Right.
Thank you, ma'am.
Thank you, ma'am. Okay.
Sir, do you have any questions?
உங்களுக்கு தெரிஞ்சு போச்சு சார் அது அது இல்ல மைக் ஆஃப்
Hello, sir, do you have any questions? If no, I think we can move forward with our next attender. Murari, are you here? Okay, I guess he's not. Let's move forward with Dhanushwari. Dhanushwari, are you present? Dhanushwari. Okay. Abhiraj. Abhiraj, can you hear me? Sayyid Yasin, are you here in the meeting?
Yes, ma'am. Hello.
What's your name?
Sayyed Yasin.
Yeah, if you are present, you can start presenting your presentation then.
Okay, ma'am. Okay, sure. Is this screenshot is visible to everyone?
Yes, yes, you
Yes,
can
yes,
start
yes,
presenting.
yes. Okay, very warm good evening to everyone. Myself Sailee Yasin. I'm from CSE department, first year. So it's a research project idea. So the title is Agri Shield, the invisible shield for agriculture. So let's have a look in our abstract. Actually, I want to give a general information about this agri shield. Actually, it will create an invisible shield to protect agricultural crops. In an intriguing idea, it is a really newly invented innovation in agriculture and agro industries. So it is like something of sound like something out of science fiction. There are various technologies approaches, as we know, that could help achieve a similar effect. So through invisibility in the traditional sense is not practical. So I just want to give a little bit conceptual technologies that could act as protective shields for crops. So the main theme, like it is to protect crop without being visible or affecting the aesthetic appearance of environment. So it is totally dependent on like from it is used to for we have little bit environment stresses such as extreme weather and pests or UV radiation, while not be being bulky or to overall appearances of the field form. To overcome all these problems, so I created the AgriShield device. So the main theme, like a problem statement which I have collected by myself, I have approached the farmers which are getting struggle. So the main problems that I have observed in them, like they are unable to unable predict the weather patterns, as well as including droughts, floods, and heat waves, which can affect as a disturb our traditional farming practices and crop waste. So to overcome all these problems, I have created this agri shield. But there are many other resources like sensors to detect the problems areas in field, but it won't stop like natural resources like heavy rain, heavy radiation. It can't be stopped. The sensors is only useful like to sensing like where is the defected areas, but this shield is really useful. So there are some pest barriers, weather protection, nanotechnology, biodegradable options like automated smart system deploy canopies or adjust greenhouse conditions to maintain optimal growth environments. So there is weather protection also. It is like invisibly covers and it is used to protect crops from extreme weather conditions such as heavy rain as well as wind damage the crops, heavy radiation rays which can damage and crop crop burn. So these materials can allow from air and water flow but still protect plants and harsher elements. And there is a little bit like a technology like nanotechnology. So this is more advanced version of invisible crop shields based on nanotechnology. This allows the creation of materials but still provide an effective layer against environmental elements. So biodegradable options, as we know, like there are environmentally friendly by using biodegradable materials. So this impact of plastic waste, we can reduce it while offering protective benefits. And real time adaptation is like the shield adjusts dynamically to weather conditions, providing continuous protection as needed. So while coming to, I just want to give a little bit introduction how it gonna works. So there are four major parts like UV protection and weather monitoring, as well as hydrophobic coating and pest and inspect control and drainage and climatic controls. As we know, like pest and inspect control UV radiation, this shield may absorb the radiation and the amount of light needed, and it will provide the shield will provide the needed amount of light to photosynthesis. So by that we can reduce the risk of sunburn practically in crops sensitive to UV exposures like tomatoes, grapes, or certain vegetables. So as we know, so and some pest and insect control by this invisible crop are made from fine almost invisible mesh materials that prevent pests and will allowing airflow and light. These shield are practically effective, like it don't harm it won't allow the insects to come in front in a field, but it can be control the damage of the crops. And this material how it works I want to explain is like it has a physical barrier like aphids, beetles from coming in direct contact with the crop. Since the mesh is designed to be fine and transparent, it can be visually undetectable, and its protective function. So weather protection, as I said, like we can protect by using this shield by wind, rain, and hail and frost. And the main major part about it is like it gonna work with the biodegradable materials or made up from plant-based and eco-friendly polymers, protect crops in the same way and traditional way. So it can decompose when exposed to natural elements like water, heat, and microorganisms. So while coming to nanotechnology, as I said, which is used to like thin and broad layer, which can helpful to convert the shield in a very practical way, that it can have that active sensors. So invisible crops are equipped with sensors and with smart technology. These materials can respond to environmental changes like temperature fluctuations and providing additional protection which needed. So the overall summary of how the invisible crop shield works, like UV blocking, pest control. UV blocking, as well as it blocks the, filters the UV radiation to protect crops, and it is used for pest control, like is a barrier which control the light and to pass through it, as well as weather protection and nanotechnology. Weather protection, like shield crops from, it will protect from heavy rain and sunburn, and about crops, insects, and shield crops from wind. So nanotechnology used as like self-healing and ultra thin layer, which is like advanced protection. Until now there is no new innovation in agro industries, as I research about it. So biodegradable options, environmental friendly materials that break down after use. These shields are effectively maintain the natural growth of crop, which will providing essential protection we are noticed by farmers and other resources. And the main benefits of this, like environment sustainability, enhanced crop health, like aesthetic appeal. Since the covers of invisible are nearly transparent, they do not disturb the visual appeal of agriculture field. And both crop production as aesthetic consideration will be protected, and reducing the need for chemical pesticides and other harmful interventions. And it is useful to protecting crop from extreme weather, and it can be generate the crops in protects all type of crops in various conditions, climates. We can grow all type of crops in various climatic conditions by this shield. And finally, I just want to conclusion, like we can completely create by this shield, we can protect the crop from heavy rain, and a combination of hydrophobic coating and transparently we can see the field, and we can control it. It reduces a human intervention in the crop field, and the farmer can be get a highly alarm system, like the AI also be improve. AI is artificial intelligence is needed in this, because to help to in like internet of things, to data analyze like weather conditions and the weather protections. So it will sense the predict the analysis and data modeling, like by analyzing factors such as temperature, humidity, and soil moisture. AI can predict when the crops are at risk of stress, automatically deploy covers needed. So autonomous systems for covering mechanism, like a robotic automation, which will gonna use in like covering the shield, as well as AI can automatically deploy crop cover based on the needs of and environmental factors, and position covering with precision. Self learning, like it can sense it before by using sensor integration, and soil and environment sensors also used in this. So adaptive coverage also can be like the system adjusts the type of covering based on the specific needs of crop. Optimizing algorithm also is needed to this system to update and reduce the allocation. The AI system can decide where to allocate resources most effectively, such as certain fields or areas with a field based on their condition crop. So the main, I just want to conclude that is it is very much useful for the upcoming future days, like using like hydrophobic coding and smart climate control and soil engineering. And by this we can improve the AI, artificial intelligence in crop field also, to not fully invisible, as well as these methods offer way to manage and mitigate the effects of heavy rain on crops. And thank you so much for giving this opportunity, and I'm very much delightful to give this presentation in front of you all. Thank you.
Okay, Yashin. Please go to the first slide. I would like to revisit your title, project title. So you have come up with the Agri Shield. So this, have you started with the implementation of the project, or you are only on the problem statement now? I mean,
No.
figuring out how you are going to go ahead.
Yes, ma'am. We didn't implement until now. It is like a research project idea, but we are yet to
Mhm.
complete a research process.
Good,
So
good. Okay. So see, the idea, what I feel is relevant to sustainability goal that our country and the world is looking forward for. But what I feel is, as a student, and if you are you are doing a project considering your timeline and everything, this is a very it will be a very exhaustive project. Okay, please get in touch with your mentor and try to narrow down the area,
okay, ma'am.
because this itself is a huge project which an organization can take into consideration, not a student for their degree or for a
Okay, ma'am.
semester course. Okay, so what I feel is that the idea is good, but there is a lot to be done with the brainstorming,
Yes,
and also
ma'am.
you have to zero down to what one aspect you will consider, because towards the end you mentioned that you're going to use AI, you're going to use robotics, you're going to use many other technologies for resource allocation and so many aspects. It is not possible for one student to do it all at once. So you will have to focus on one aspect, and even in that one aspect, you have to narrow down which process you're going to use, and accordingly frame a block diagram, come up with a flow chart, come up with what are the models you're going to use. Then I think you
Okay.
will be in a position to start with your project. Okay.
Okay, ma'am. Okay, ma'am.
Yeah,
Thank you
that's
so
from
much.
my end. Maybe Sir can also give an input here. Okay.
Okay, ma'am. Thank you so much. Thanks a lot. Thank you so much. Thanks for giving this opportunity. Thanks a lot.
Sir, do you have any questions for Yasin? I guess sir has no questions. Let's move forward with our next presenter, Abhiraj Sarunke. Are you here, Abhiraj?
Yes, I'm you.
Please start presenting.
Am I visible?
Yes, you are.
Yeah. So, hello everyone. My name is Abhiraj Soundke. I'm from Sanjivani University and studying BTech in AIDS. My project name is Farm Connect. So, my problem statement is farmers are not getting to know about new technologies, and many farmers are unaware about new technologies, and they are still using old products for their farming purpose. So here is my project objectives and goals: to develop an application for only farmers, where farmers are get to know about various new technologies about farming, where every developer can upload their new product, and user, which are farmers, can easily know about it and use it, and can also order through our app. So farmer can also connect to different state farmers and can contact to each other, uh, and also suggest their new innovative ideas about field, and whoever the developer is can implement on it. So empathy map and persona: Our app is for farmers, and farmers are also suffering from problems because they are not getting new technology. They need the technologies to make their workload less. So through our app, uh, I will I will help farmers to get new technologies, and this app is only for farmers and product owner and seller. This app include all languages like Hindi, Marathi, English, Punjabi, etc. Can all ages farmer can use this application easily. So brainstorming, farmer organization, high investment cost, poor connectivity, less knowledge of technology, high investment, poor coverage, research, agribusiness, and theory of prioritization. So log in through Google account or iPhone, you can use it. Farmers want to buy afterwards, so they can wish list it. And new product can sell in the application by farmers, buy or sell product by owner and farmers. And farmers can also earn money through our app. uh, Here is the innovative about application. So technology stack, software like Flutter, Flow, uh, to develop application, and POS, retail POS software is the that regards sales transaction at point of sale. GPS insight, because farmers want to connect with each other, so GPS. And also we consider our weather, programming language like Python. So key outcome and learning. So farmer can easily share resources, equipment and services, reducing cost and improving efficiency, improve knowledge exchange. Farmer can exchange expertise, discuss crop management techniques and learn best practices from each other, leading to better crop yields and farmer methods. Farmers can share real-time information on crops, prices and demand, helping them make more informed selling decision and maximum profits. And this platform uh, enables collectively purchasing and giving farmers the power to buy inputs in discounted rates. So future steps, here are the future steps, uh, like scale user base and regional expansion objectives. Expand farmer connect to reach farmer across different regions or countries. uh, and partner with local agriculture bodies for targeted outreach. Enhance performance features objective, build on existing platform which more farmer can use our technology. And here we can also introduce new models for weather forecasting and crop disease identification, etc. So develop data analytics and reporting objectives. So provide actionable insight to farmers based on usage data trends. Action use data analytics to generate reports on market trends, crop performance, and best practices, etc. And fourth, strengthen partnership and collaboration objective. Create a network to stakeholders, including agriculture suppliers, local cooperatives, and government bodies, etc. So partner with suppliers for discounted inputs, where um, uh, farmer can use our app and also sell their ideas or implement their ideas on our app. Thank you.
Okay, so please take me to your first slide, the title slide where you have the project title. Farm Connect. Okay. And the features where you mentioned about the features that you're going to connect, right? Implement.
Yes.
Can you show me that?
Yes.
These are the softwares that you're going to use, right?
Yes.
Flutter and okay, fine. Python you're predominantly going to use. Okay, so the as far the software you're using, what about the hardware? Will it be mobile based or how is it?
Yes, it will be mobile based only.
Okay, okay.
So
So again, my question here will be because the same question will apply to the previous candidate who presented. Since you're talking about the agriculture and farm and all that, so definitely here any to ensure that your data there is no data lagging and jitter. So better you use edge computing. Okay, the idea of edge computing is very simple. The I mean, most of the computation happens right in the device which is on the field. Okay, so you can use that. It's not a rocket science. Try implementing that also. And I think you have just figured out the title and the project that you're going to work with. Have you started with the implementation?
yeah, just like basic, I have started a Flutter Flow.
Uh-huh. Okay. Okay. Fine. So also, if you are going to manage is there any AI implementation that you're going to consider in this project?
Not yet, but I'm trying to use AI.
Mm. I will suggest please try to use at least a chatbot because many a times, in the chatbot you can go for the instead of text based, you can go for audio based. Okay, so
Yes,
the farmers can instead of typing and all because they may not be so comfortable typing, right? So they can speak in their language and the system can respond back with an appropriate answer like that. Okay,
yes. Okay.
yeah, fine. Okay, thank you.
Thank you.
Sir, do you have any questions? Rajesh, sir.
No, madam. We can go with the next. Actually, Rajesh sir left. We can go with the next participant, madam. Okay.
Okay, sir. Thank you. Let's move forward with our another attender. Um, Suguna Shri, are you here? Hello. Suguna Shri. Hello, Suguna Shri, are you here? I guess no. Jay, are you here?
Yes, Sailee. Am I audible?
Yes, you are Jay. If you are okay, you can start your presentation.
Yes, just a second. Sailee, is my screen visible?
Yes, it is. Jay, your voice is echoing.
Sailee, just a second. Hello, am I audible?
Yes, but your voice is echoing.
No, am I audible, Sailee?
Yes, you are. You can start.
Yes. Yes. So, good evening, esteemed panel members. Imagine this, you're sitting in a lecture hall, the professor calls out the roll, and a few students quietly scribble their names on a sign in sheet, while some might even pass it on to their friends. Sounds familiar, right? But here's the problem. This outdated system is not just time consuming, it opens door for misuse like proxy attendance and increase the risk of errors. Now, picture this. What if we could completely eliminate this issue with a solution that's fast, secure, and vulnerable? I am Jay Jobanputra and I'm excited to present Attend Max, our innovative solution to the age-old problem of inefficient and insecure attendance tracking in educational institutions. Currently, many schools and universities still rely on manual roll calls or sign-in sheets, which are not only labor-intensive but also prone to errors and misuse. This not only undermines the integrity of attendance process but also wastes valuable time for both students and teachers. With Attend Max, professors can generate unique QR codes for each class, which are displayed on the screen. Students simply scan those QR codes using our Attend Max website, marking their attendance instantly. The system captures all the relevant data, including student names and PRN numbers, ensuring real-time, accurate, and secure attendance tracking. The beauty of the system is all the attendance data is automatically recorded in an Excel sheet, making it simple to manage and review, all while eliminating the risk of proxy attendance. Ma'am, can I show you our website?
Yes, please. I'll be happy to see that.
This is our student interface. As you can see, overall attendance as first criteria for colleges is 75% attendance is compulsory for everyone. From here, you can scan the QR code and uh, scan. Sorry, you can start the camera and scan the QR code over here. Here you can see the subject-wise attendance for each subject.
So for a specific subject like for mathematics, if I want to see how many students have turned up, can the teacher have a look on the name of the students?
Yes, ma'am. Just a second. I'll show you the admin interface.
All right.
So, ma'am, this is the admin interface for us. You can select the department and subject and generate a QR code. Ma'am, you can see here a 15-second timer is going on above. This is because like first problem will be students can send this QR codes on WhatsApp and their friends can scan it from home. But every 15 seconds or 10 seconds, a new QR code will be generated. As soon a new QR is generated, the old one will get disabled. So the time still anyone sends the QR code and he or she scans it from the home, the QR code will be disabled from there.
All right.
And here attendance record, you can see for John Smith or Sarah Johnson, they have been marked absent if they
Okay, so this is very interesting because my question was again when you mentioned about generation of the QR code, the first thing that came in my mind was the images, the QR code can be easily shared through the WhatsApp. But you're saying that after every 15 seconds that it will be changing. So I mean, still that doesn't prove it that because our students are also very. I mean, you guys are student, you know it that it's very easy to just within a fraction of a second you can just copy and share it with your friends, right? And
ma'am,
considering
yes,
the
But
yeah, timeline, they will
but
also
ma'am,
be
if
waiting.
yes, ma'am. But as we have used phone pay, we get two options over there. You can like go in gallery and then upload the QR code, right? But we are not giving that option in our website. You just have to open your camera compulsorily and then scan the QR code. At the same time, the WhatsApp and the website both cannot be operated. You can upload the QR code on the website to scan it.
No, but let's say I'm a student here now, you're a teacher, and the QR code is right in front of me. I can just take a photo of it and share it with my friend who is outside, right?
Yes, but
And
ma'am, when
within that few seconds, he can also immediately mark it.
but ma'am, like see, the QR code will be on WhatsApp. How will he put it in the website? He will
Why?
need that option to upload it.
Yeah. Let's say in the right in the beginning it's a because 15 second you have taken.
Ma'am, we can reduce
Uh,
that time. Like it's for just for trial purpose. We can reduce that time to 5 seconds or 6 seconds even.
mhm.
That's not the
No, the
problem.
idea is good. Maybe just think a little bit out of box and how you can avoid the proxy attendance. Then I think your project will definitely stand out from because we already have the QR code patterns of recording the attendance. So how do you
Yes.
stand out? How does your product stand out from the others? That part you just try to focus. Okay.
Yes.
I think this is good, but I think you have to think something else more than this to
Yes.
avoid the
And ma'am,
proxies.
one thing we are going to add is if you have been marked absent, those who have marked been present, it's okay. But those who are going to be marked absent, they will receive an email that you have been marked absent for this XYZ lecture. Contact
Mhm.
your mentor or mention the reason for your absence.
Mhm. Mhm. Okay,
So,
that's also good. Mhm.
like the mentors will get the reason for the students absent on the same
Right,
day.
right. Hmm. Good, good. That's fine. That's nice.
Okay, ma'am.
Okay, so this is the project, or you're still thinking to add some more features to it, or for now you're keeping this as a project alone?
Ma'am, like 60, it's 80%
Mhm. Hello, hello. I could not hear you. Hello.
Jai, you're not audible.
hello.
Yes, you were saying something
Yes,
80%.
yes, ma'am. Like this project is completed 80%, but for
Uh,
20% we have to work on the databases and data sets, which will be providing over here. But
uh,
in upcoming 15 to 20 days, it will be ready to launch.
okay, good, good, very good.
And
Try
like we have
also,
to,
huh? What is
yes, ma'am.
what can you do with the implementation of AI here? Can you implement AI here? Have you thought in that line?
Ma'am, one thing we can do is take a machine learning model. Like as you said, teachers should be able to see number of present students or absent student.
Mhm. Hello, hello.
Column over there at the same time.
Yeah, in between we lost you once again. Machine
Uh,
learning model.
uh, there's like two things. One thing is those who have been marked present, they can be seen. It's okay. But those who have been marked absent, at the same time, the separate list for them will be generated over there. So for each day, number of students present for each lecture and absent will be same seen on the same side. We can
Mm.
use that machine learning model over there.
Okay, okay, good, good. Good to see
And
your.
then our future plan is like our college has purchased a ERP which is worth 15 to 20 lakh rupees. If
Mm,
we like sell this in a subscription model, still it is not worth it for them to purchase it. So we are
mm,
open to both. We can also like collaborate with them and just provide our feature to them. And the
mm,
colleges who are not eligible to purchase that 15 20 lakhs of ERP will create own our ERP, a proper student management system, and then sell to
mm.
them. Our future plan is this.
Good, good. Try also putting it in your mobile format, the mobile phone format, and you can do a test drive with trying in your own class with your teachers or in the
Yes.
coaching centers nearby and enhance your product depending upon the requirements, and then slowly you can proceed. Okay, good. Thank you.
Okay, thank you, Jai. Let's move forward with our next. Suguna Shri, are you present?
Yes, ma'am. Am I audible?
Please. Yeah, you are. Please start presenting.
I'm interrupting for a bit. So today it extended a bit long. So I would request Shunashri to please be concise and try to complete as soon as possible, so that we can declare the results and recognitions today itself. Thank you.
Okay, sir. Okay, sir. Can I start, ma'am?
Yes, sure, you can.
Is my screen visible?
Yes.
Good evening, everyone. I'm Sugunasri from Arupadai Video Institute of Technology. Currently, I'm doing my BE CSC first year. So today, I'm so excited to present my discussion and research work, which talks about the role of AI in space technologies and how AI helps in unlocking cosmos and space missions. So let's look further into the presentation. Okay, let's look into the abstract. AI enhances the space communication by making systems effective, reliable, and adaptable. It reduces the human intervention. When I say the human intervention, the AI systems autonomously can manage communication tasks, reducing need for continuous human monitoring and decision making. It also optimizes the bandwidth usage by managing the with by prioritizing and routing data. The AI also helps in reducing and ensuring the smooth communication between Earth and spacecraft. Additionally, AI-powered systems detects the anomalies, performs errors correction, and support critical operations. So, when we look into this crucial role of AI in space technology across various domains, coming into autonomous spacecraft rovers, AI enables spacecraft rovers to navigate and make real-time decisions without a need of human, where the direct communication with Earth is limited. So while coming to satellite operations, the AI is used to process and transmit large amount of data for Earth observation. In mission planning, AI aids trajectory optimization and aids in finding the resource, improves the mission efficiency. AI also helps in making research and processing large amount of astronomical data, analyzing cosmic phenomena, and discovering the celestial bodies over the cosmos. So here comes some more AI driven technologies through the space innovations. So in spacecraft health monitoring, this system predicts the failure and diagnoses the reliability of the spacecraft. This is driven by predictive sensor data fusion, automated fault diagnosis, and anomaly detection algorithms. It is nothing but machine learning algorithms to identify unusual patterns in sensor data indicating potential system failures. While coming to astronaut assistance, AI, this astronaut assistance is nothing but it monitors the health of the astronaut and also helps in operational tasks. This is run by virtual assistants, natural language processing, emotional intelligence analysis. It is nothing but detecting emotions, fatigue, stress, and other concerns of astronauts. Personalized recommendations, which are trained for this model. While coming to space mining, it is nothing but an AI modeled robot which collects the samples from the space and bring back to the Earth. This is driven by autonomous navigation system for by which the mining equipment is built, ensuring the efficient and safe operations. Optimizing the this helps in optimizing the mining operations. It makes the task much efficient. In deep space exploration, the AI aids in autonomous navigation, anomaly detection again. For this, machine learning algorithms is used to identify the unusual patterns in sensor data. Predictive modeling, AI-powered predictive models to forecast spacecraft performance and enables proactive adjustments and optimization. Decision support systems. While coming to space weather forecast system, data fusion, predictive modeling, automated alert systems are used to notify the astronauts and mission control for space weather threats. So overall, some of the key AI technologies used in these applications are ML, deep learning techniques, which includes neural networks, RNNs to analyze complex data, natural language processing, computer vision. So these are some of the innovative ideas which are driven by AI, which can push up the space technologies further, such as AI enhanced spacesuit. These are built up by sensor systems, advanced sensor systems, which analyzes the temperatures, pressures, fatigue in the space environment, and adapts the conditions to the astronauts. While coming to AI-powered space drones, these are built by autonomous navigation systems, AI-powered navigation systems such as LiDAR and GPS to enable autonomous flight mode. Sensor suits, swarm intelligence, it is AI algorithm to enable multiple drones to collaborate with each other, and this particular technology is used to communicate drone to drone and use it to adapt the changing in environment. Space colonies, it is a modular architecture actually. It is not yet, it is just an idea. So it talks about the oxygen levels, controlling climate, and the space weather conditions, and the sustainability which we can take up in space. AI powered space junk cleanup. This is built by debris detection systems, robotic arms and grippers, tethering and towing systems, which detects the waste or unwanted things which cause trouble to the satellites or space station systems, and which are located in the orbit of the satellites, and they clean up this. So for this purpose, the AI powered junk cleanup is built up. So the coming to the problem statement of the of my presentation. Currently, the space system relies on ground-based operation. This causes delays, high costs, and inefficiencies. AI-powered space technologies can enhance autonomy, optimize communication, and enable real-time decision-making for spacecraft and satellites. However, challenges remain in ensuring the reliability, security, and ethical deployment of AI in space. So my aim is to develop AI-driven solution which can enhance mission efficiency, reduce operational costs, and enable more autonomous and intelligent space exploration. So the overall objective is to improve the space mission efficiency by integrating AI technologies such as machine learning, which helps in real-time data processing, real-time decision making, autonomous navigation, ensuring adaptive control, fault detection, and optimized bandwidth use. Conclusion is, as we continue to push the boundaries of space exploration, AI-powered space communication will play a role in facilitating seamless connection between Earth and space-based assets. Thank you.
Okay, so the idea about trying to come up with a AI-driven model for streamlining the space technology is really good, but it is a very advanced. I mean, it's a very vast topic in itself. So you need to come up with something very concrete for what exactly you're going to do in this. Okay.
Okay,
Yeah.
ma'am.
Yeah. And in presentation like this, you have to be very specific rather than, because I think the first two slides, first three slides, you're talking in general. That is not required. We would like to know what you are planning to do. Okay.
Okay, ma'am. Okay, ma'am.
Yeah. Okay. Thank you.
Thank you, ma'am. Thank you.
Okay, thank you so much, Suganshri. Now we are over with our participants and presenters. Let's move forward. Um, I ask all to wait for few minutes. Thank you to all the attendees and presenters for your contribution. We appreciate your efforts. Now we will proceed with shortlisting a few presenters based on their scores. The shortlisted presenters will be required to present once again for the final evaluation by the jury. Following this, the best paper and best project recognition will be announced. At present, there will be few minutes break while the jury deliberates. I request everyone to please stay in the meeting for 5 to 10 minutes more. Thank you for your patience, everyone.
Hi, Usha ma'am, am I audible to you? Vengatesan sir, am I audible?
Yes, sir, you are audible.
Okay, like Vengatesan sir, am I audible to you? Usha ma'am, am I audible? Sailee, am I audible to you?
Yes, sir. I guess Usha ma'am has left
Okay.
the meeting.
Yeah, most probably. So, like the presentation really went well, and now it comes with the results and all. So due to some technical glitch, it's getting delayed. So most probably by tomorrow morning or by tomorrow, like it will be given. So I would request everyone to bear with us and wait for some time. And every best paper and best presenter would be announced via email. So let's conclude for today, and we can discuss tomorrow and circulate the same tomorrow. Thank you. Shelly, you can proceed with the conclusion.
Okay, thank you everyone. Thank you, jury members, for today. And all the presenters, you did very well and very great. I am sure you'll all get your appreciation for today's presentations, and all the attendees. I respect your patience for today so much. Thank you, everyone. Thank you so much. Thank you, Finessefleet Foundation, Sanjivani University. We'll continue with the results tomorrow. Thank you, everyone. You can now leave the meeting.